Here what we're going to do is we are going to mimic the data engineering pipeline over here. Just imagine that in case of MMM, you have a couple of data sources and data engineering pipeline is going to connect to that data sources and it will get the data, it will do some ETL, it will run some validation and post that is done, it will write the data into the project DB, right? So here we are going to mimic the same process. So just imagine that here your data source is like data sets, which is coming from sklearn, and from that you'll get a data set which is called iris, and you'll write it to a DB. And before you write it to the DB, you'll do some pre-processing. So here we are using SQLite, and the DB which this script will create is data.db. I'll just delete it from here. Now, once we execute this line, it will show us that the engine is valid or not. What it means is like the connection between the DB and the pandas is working or not. As we can see that we have created this data underscore db.db in local, which means this DB is present, and also it says engine is valid, which means that it is able to create a connection between the engine and the vendors. Now here we are extracting the iris data, and after we extract, the data set will look like something like this. As you can see that here we have some of the headers with space and this first bracket centimeter suffix, which is like maybe this is not something how we should save the data. So let's imagine that here the ETL represents that will clean the header, will remove any blank space with underscore, and also will remove this centimeter with blank space, right? With no space. And after we pre-process the data, it will look something like this. So let's say like now we have the clean data. We want to see what is the shape, and we know that we have like 150 rows and 5 columns. Now, when we are saving this data in data engineering pipeline, we need to specify the column name and what are the respective data types are. So here we are specifying that it will be float, the precision will be 4 decimal, and the target will be integer because we have passed it as integer and it has like encoded value between 0 to 2. So after we execute this, ideally one table called iris will be created in the DB server. We are not storing the index. If there is anything present, we'll replace the data and it will load it in chunk size of 100 and it will open multiple connection and load this. Right? So if we execute this script, we should have one file created over here. And if we take a look into this, you'll see that there is just one table created and it has like some of the value which we have just seen. Right? So these are the rows, and yeah, I think this is kind of a demonstration of the data engineering pipeline, how the data will be collected from source, how we'll run a ETL, and how we'll save it in a project DB. Right? Now let's say once this data is like saved in a project DB, ML pipeline will be triggered, and what it will do is it will read the data from the database, the respective table, and then it will build a model in order to generate some coefficient. Here in our case, this will be the response curves which will be generating. So if I execute the script, here we have one more function which will take the sklearn model object and it will parse it as a JSON and will store that in a DB. So here again we are creating a connection with the DB. Here we are checking that the DB connection is established successfully or not. And if it is successful, we are reading this table from the DB, and the table after retrieving the table, it looks like something like this. So here, as you can see, that we have like 150 rows and the column names are looks fine. So we assume that we have successfully retrieved the data. And now what we are doing is we are creating independent and dependent variables. So we'll just execute this, and X will look something like this. So as you can see that there is no target variable, but all the other columns are present in X. And now if we take a look at Y, which will look like this. So this is the Y, and this is a 1 column data frame, and this is like a data frame with 4 columns, right? So we'll pass these two in our logistic regression, and then we'll get a response. And basically here we'll fit this X and Y, we'll pass this model object to logistic regression to JSON, which is nothing but it parse the same model object to a dictionary with couple of parameters, and it returns the value. So here we are running that. So if you see here, like after building this model, we are passing this model as argument to this function, and we are getting a response. Now here we are creating a model ID, and this model ID, we are creating a data frame with two columns. One is model ID, another is a response. This response is nothing but a dictionary. This is a model ID, which is a string, right? So if we execute this cell, the output will look something like this, where we have a data frame with a UUID, and then we have a model output or model parameters passed as JSON. Now I think we are good to save this in a DB. Before doing that, we'll just check the object type. So both of these are like objects. So here what we can do is, as a one more step, what we can do is we can pass it as string. Then we can save this. So here, although it is showing object, it is string. In Pandas latest version, the data type has changed from object to string. So latest Pandas version, it should come as string. And post, we are like once we are happy with the data type and the data frame, we can just write it. So same, we're using the same engine. We are creating a new table. If it exists, we are planning to replace it. We're not storing the index, and the data type of response is JSON. And then model ID is nothing but a string. We are loading it in chunk size, although it is not relevant here. Method is multi. We can just, so this will be just adding one single row. This thing does not make much sense, but we can keep it as it is. Now, once we execute, we can validate the same here. Refresh this. Now, see that we have like a new table, model parameters with model ID and response. Now, once we have this thing saved in the DB, next step is to upon model serving, where we can load the data, and then we can use the same data for prediction purpose. So here we have one function which takes this JSON and parse it to a sklearn object. And here we are creating a connection with the DB. Here we are checking that the DB connection is alive or not. And here we are retrieving the table and the X values from the table present in DB. So the X value looks like something like this. And then what we are doing is we are querying the model parameter table. We are matching the model ID with the generated model ID, and we are parsing it. We are parsing the coefficients or model object as JSON, which looks like this. Now, once we have this object present, we'll try to parse it as a sklearn model object, and then we can predict the X values just to double check that everything is working fine. So as we can see, it is able to predict this. Now, one important thing is that this model serving will be executed in API, and this storing of model object in DB will be executed in a ML pipeline, and also this the first step shows the data engineering pipeline.